I'm excited to present CatDB, an LLM-based framework for generating data-centric ML pipelines. This novel approach integrates large language models to automate the creation of high-quality ML pipelines. Specifically, our method enables end-to-end pipeline generation by leveraging structured data catalog to guide an LLM decisions. Imagine an end user or data scientist analyzing a domain-specific dataset without being a domain expert. Given a tabular dataset represented in a single or multiple files and an ML task such as the classification or regression, our goal is to build a data-centric ML pipeline. CatDB focused on profiling domain-specific dataset, precisely filtering and projecting metadata, and utilizing LLM to generate ML pipelines. CatDB can be used with a few lines of Python code to enhance understanding. We have broken down the generation process step by step to main prerequisite in building a data catalog in line number 4, followed by refinement in line number 5. The data catalog materializes metadata for each column individually, including table and column names, statistical values for numerical columns, and more. Additionally, general metadata such as number of rows and columns and the dataset physical path is also materialized. With metadata in hand, we constructed context-aware prompt, a template specific to an LLM. First, we inferred instructions essentially for ML pipelines. For instance, if certain features contain missing values, we add an imputation rules for the prompt. Second, we include metadata related to inferred rules to guide the LLM in making precise decisions. Finally, all of this information is combined into the single prompt using a structured template. The generated pipeline API in CatDB interactively communicates with LLM to generate and execute the ML pipeline. Additionally, CatDB includes a self-error correction mechanism for syntax and runtime error. Let's see CatDB in action. After installing the CatDB and necessary repositories, for example, data profiling, we configure the LLM by specifying the model name, for example, Gemini 1.5, and API key and number of iteration. Our prepared dataset API simply split our dataset to training and test set while describing ML tasks. For example, binary classification for predicting income target attribute in adult dataset. After that, we are submitting our data to build catalog API in order to extract and materialize the metadata. Our create report for catalog can visualize and show us the entire of the extracted metadata from raw dataset. For example, dataset overview, feature types, missing values and present frequencies, and categorical and frequency of them. Next, with data catalog and LLM configuration, we can generate actual ML pipeline and execute them by generate pipeline API in CatDB. Again, create report for pipeline output can visualize and shows us what's happened in the data catalog and can generate pipeline API. First, pipeline runtime can show us generation time, verify time, and execution of the pipeline. And also, we can visualize the performance of the generated pipeline models and number of consumed tokens and error types and frequency of them individually for each iteration. Next, for the system prompt and catalog data, we hierarchically visualize the constructed prompt by describing a system prompt and catalog data. For example, task description, dataset description, and extracted rules and corresponding metadata for each rules. The SRC number 127 tabs can show how the actual ML pipeline generated by CatDB by utilizing the LLM. The end user can easily follow the data pre-processing, feature engineering, and model selection